The car is traveling at a speed of 30 meters per second. The driver applies the brake at A, and the speed reduces at the rate of AT equals minus T over 8. So AT is a function of time. If it takes the car 15 seconds to travel from A to C, so the time from A to C is given. Determine the acceleration of the car when it reaches point C. So we need to find the acceleration at point C, which consists of two components because it is inside the curve, AT and AN. Now AT is given in the problem. It is minus T over 8, and the time is given so we can find the AT directly. However, we need to find AN, which consists of V square over rho. So we need to find V, and rho also is not given in the problem, so we need to find rho also. Okay, so let's start with the velocity. AT is given as a function of time, and the time is also given, so we can use AT equals dV over dt. We take dt to the other side, and we integrate both sides, taking care of the initial conditions. V naught equals 30 when T naught is equal to 0. And by doing this integration, we will get V as a function of time. So as we just said, AT can be directly found from the given information. It is minus T over 8 after 15 seconds. This is given. However, AN needs two unknowns. One of them we just found, which is the velocity. So we can find the velocity after 15 seconds. And the other one is rho. So how do we find rho in this situation? If you look at the curve between B and C, you will find that the only way to get rho is by using the definition S equals rho theta. And since we know the angle, which is 45 degrees, we can use that between B and C. So now S is equal to rho times pi over 4. So if we find S at point C, we can find rho at point C. And since we have V as a function of time, and V is ds over dt, we can integrate both sides, and you will find out that the only unknown here is S after 15 seconds. So the total distance from A to C is S plus 100. We started from origin S not equal to 0 when the time equals to 0. And after 100 meters plus S, the time is 15 seconds. And if we do that, you will find out that S is your only unknown, and you can find it to be 279.7 meters. And now rho can be found from our equation, which is 4S over pi, and this is 356.1 meters. So now everything is found. We have V at 15 seconds. We have A of t at 15 seconds. We have the normal acceleration also after 15 seconds, where we found V and we found rho. And the total acceleration will be the magnitude, which is going to be 2.01 meters per second square. And to summarize, the key to solve this problem was to find the velocity and the radius of curvature rho. So time is given at point C. AT is a function of time. So we used the definition of A of t to find V, and then we used V to find S from its own definition, and then by finding S, we used the relationship rho theta to find the value of rho after 45 degrees.